Hello again. I haven't given up. I'm still working on the controls for my Dixon ZTR. This is the sticks that controls the drive of the original machine. I've cut this off with a grinder and then I put on the thumb throttle on the sticks. Bolt placed on it that push the throttle stick. So when I'm moving the lever, the throttle will increase. They didn't actually fit on the axle, so I had to put some copper piping in between. Now we can move the sticks forward and back, and that activates the throttle. So here I have the throttle as in a simulation. I move it forward, and the motor increase and decrease. So this is a walkthrough of the code I created with ChatGPT to control the Dixon zero-turn electric mower. Firstly, we defined all different connections and pins we'll be using to control the motor and read the joystick values. This is pins on the Arduino board that I'm using. A0 for input for one joystick side and A3 for the other. We have motor output with pulse width moderation, EVM, on the 9 and 10 for the motors. We have brake for side 1 and brake for side 2. And we have reverse on 7 and 12. Next, we set up the initial values for parameters such as dead zone for the joystick and limits for the motor control. So we have a dead zone between 412 and 612 as of now, where the motor shall have brake applied and be standing still. Uh, we have also a top limit and a lower limit at 100 and 920. This is to allow for play in the joystick up and down. In the setup function, we configure all the pins as either inputs or outputs and set the PWM frequency for the motor controller. So I have increased the frequency of the motor controller from the original. I think it was 420 Hz. So this should make it more smooth. Uh, Moving on to the loop function, we start by reading the raw joystick values for X and Y axis. Then we convert the raw joystick values to fit within the new dead zone range. So this is the play that I talked about earlier, where we filter out top and the lower values. Now comes the interesting part, where we control the motors based on the joystick values. We check if the joystick is within the dead zone, and if so, we turn off the motor and invert the brakes. So this is applies the brakes when the joystick is in the middle in the dead zone. For joysticks values outside of the dead zone, we use an exponential scaling functions to gradually increase the motor power based on how much the joystick is pushed. So when we go over the dead zone, the motor will increase from 0 to 1023. And if we go under the dead zone, the motor will also increase from 0 to 1023. So the motor will increase on both sides of the dead zone. So increase in reverse and decrease in forward. And we apply the same logic to the second motor, of course, so that we can turn the machine by running one motor forward and the other one backwards. Finally, we send the calculated motor values to the motors using PWM and also control the direction of the motors based on the joystick position. Yes, and then we also print out the values to serial monitor to monitor the system. So this is what you can see on the computer when you are running the system and are connected to the board. This is helpful to see if the program and the board reacts correctly to your input. So that was a walkthrough of the programming. I have used ChatGPT to do this, and it's rather simple. You have to explain to ChatGPT carefully what you want to do, and it will write the code for you. I can control one motor, but, but it only moves forward, even if I have low throttle on. The stick does not work. I also have a problem where I connect both motors. One stick will control or affect both of them. I will have to investigate this and get back to you in another clip. Goodbye and see you later.